We have four logical operators in Visual Basic. The AND, the OR, and the XOR are looking at two different expressions and evaluating those together. The NOT is reversing the truthfulness of an expression. Let's look at each of these a little bit more in depth. So the AND operator takes two Boolean expressions, puts the AND in between, and if they are both true, Boolean expression 1 is true and Boolean expression 2 is true, then the whole expression is true. However, if one of them is false, let's say Boolean expression 1 is false, then that whole expression is false, or if Boolean expression 2 is false, the whole expression is false. And of course, if both expressions are false, the whole thing is false. This little table over on the right-hand side is what we call a truth table. And so we see the value of expression 1 and expression 2 and the result. So again, for an AND, both expressions have to be true for the whole expression to be considered true. For the OR, the whole expression is considered true if either side is true or they both are true. Let's look at this example here of x, y, and z is 1, 2, and 3. So if x plus x is 2, that's true, and y times z equals 6, 2 times 3 equals 6, that's true, the whole expression is true. If x plus x is 2, but y times z equals 5, 2 times 3 equals 5, that's false, it's still true. If either side is true, it is true. The third example here, the left-hand side is false. 1 plus 1 does not equal 3, but y times z does equal 6. 2 times 3 is 6, so therefore it's still true. And then the last one, they're both false. 1 plus 1 does not equal 3, and y times z does not equal 5, therefore that whole expression is false. So again, we have the truth table for the OR over here on the right-hand side. If any side is true, the whole thing is true. The XOR is what we call an exclusive OR. It basically works just like an OR, with the exception that if both sides are true, then the expression is false. I have to be honest, I can't think of a project that I've used the XOR on, other than for a bitwise operator to flip the flag of an enum. And we saw that in a previous lesson when we worked with the font style enum. But in doing an evaluation of expressions, I'm hard-pressed to think of an example where if you have two things are true, you want that to be considered false. But it's there for you. So that's the only difference between the XOR and the OR. Let's take a look at the NOT. So the NOT reverses the truthfulness of the expression. And it makes sense. If something's not true, it's false. And if something's not false, it's true. So in the example here, if not x plus x equals 2, then, well, that not true becomes a false. And then if not x plus x equals 3, 1 plus 1 does not equal 3, so that's false, but the not makes it true. And then we have not y times z equals 6. That's a true expression, but the not makes it false. And then not y times z equals 5 is a true expression because it's not false. And then finally, here's a summary of those truth tables of the four different logical operators. You'll recall in the previous lesson, we talked about nested conditionals, and I demonstrated this application with the track bar. We're showing the positive, odd, positive, even, negative, odd, and negative, even numbers, as well as neutral and the zero. And we use nested conditionals inside the if and else forks to accomplish that. So our outer conditional, we looked at positive or negative, and the inner conditionals looked at either odd or even. Well, let's look at how we could rewrite that using logical operators. Same application, I just rewrote the code to use logical operators of AND. So I have an if, else structure. So the first if track 100.value is greater than 0, means positive, and track 100.value mod 2 equals 0, meaning it's even, we're going to say it's a positive even value. Else if, again, the value is greater than 0, but the mod 2 does not equal 0, then it's going to be odd, and we'll say it's a positive odd. Then we do the same thing, this time though with the track 100 value less than 0 and the mod 2 equaling 0, so it's a negative even value. If track 100.value is less than 0 and track 100.value mod 2 does not equal 0, then it's a negative odd value. And then finally my else, if is it's a neutral value of 0. Which approach is better, the nested conditionals or the logical operators? They both work, and both are certainly acceptable. The execution time is going to be minimally different between them, so one's not necessarily more efficient than the other in this case. I do think that the logical operators are a little more readable maybe than the nested conditionals, and perhaps less likely to make a mistake. But either one will work. It's your choice. If you just jumped into this video, you can see all the videos from the Programming Practicum playlist by clicking on the image in the lower right. And if you'd like to be alerted to future videos I create, you can click my picture in the top right to subscribe to the channel.